Hello, how are you? A student has asked me to go over this particular question, so I thought I'd do it for everyone's benefit. So we're looking at word equations and chemical equations that are balanced. The student has made an attempt on the first one, so he was given the word equation. Remember, compounds like ethane, you're not expected to remember or know their chemical formula. So that will be given to you. So we have the C2H6. Then we have, we know it's combustion, so it's combined with oxygen. You should know that oxygen always goes in pairs, so we do expect you to by now know that it's O2 as shown. And finally, we have the products. And when it's burned properly, you'll have a clean burn, that is a safe burn, carbon dioxide plus water. You now know the formula for water is H2O and carbon dioxide CO2. So now we're just basically trying to balance. The student has made an attempt, close, one slight mistake. If I just change that to a 1, um, let's go to a review and get myself a pen. Let's change that to a 1. So let's see if that helps anyway. So we have one of the ethane that's got 2 carbons on this side, and we go to the other side, and carbon dioxide only has 1 carbon. So the student correctly put the 2 in front, coefficient, so we end up with 2 carbons. Always remember oxygen last. We now go over to the hydrogen. Here we have 6 hydrogen on this side, and ooh, we ended up with 12 here. So maybe we just change that back to 3. And so we now have 3 oxygens on this side plus 7. 4 is 7 oxygen on this side, and on this side, okay, we need to change that back to now 7 divided by 2 is 3.5. And so that's the correct formula. However, chemists don't like working with fractions. So how can we eliminate the half? Very simply double everything. So that will end up being an R. Now we know why it's C6H, C2H6. We double that. Now 3.5 double is 7 oxygens. Remember, oxygens always go in pairs. Gives us double that, 4 carbon dioxides, and double that, 6 hydrogen. So there's a 6 back again. And you can see we made just a few small changes. Let's just check now. So we have we've got the coefficient in the front, so everything gets doubled. So we have 2 carbons there, doubled is 4 carbons, 4 carbons. We have 2 lots of 6 hydrogen, 6 doubled is 12. Let's have a look at the side. Yes, we have the coefficient 6, everything gets multiplied by 6, 6 twos are 12 hydrogens. And now we have the last one, oxygen. 7 lots of oxygens times 2 is 14. Let's see if we can get 14. 4 times 2 is 8. And 6 times 1 is 6. 8 plus 6 is 14. So we ended up with the correct. So that is a tricky one. The important thing you learn from that one is the importance of chemists don't like fractions. They just simply double it. Usually will be just a case of doubling. Okay, the next two, I'll do the next one and I'll leave the butane for you to try. And the key thing here is this one is in excess oxygen. It's like it's got a turbocharged. So it's got plenty of oxygen. No problem. Get nice clean burn. That means we'll end up with carbon dioxide. While the butane is in limited oxygen. So then before we're going to end up with the carbon monoxide. So review your textbook to see for that and see if you can write the equation. Remember, you're not expected to know that, but you should know how to write the oxygen, the carbon dioxide, the water, or the carbon monoxide. So let's have a look at this one. Remember, we always start with one of each. So pretend there's one in front of there. Remember, we know that it's in excess oxygen, that carbon dioxide, and water. So we're ready to work on this. Hopefully it will be a little bit easier than the methane. So let's go. So we have three carbons on this side, so we'll need three carbons on it. Remember, you can't change the formula, only the coefficient. We have eight hydrogens on this side, so we'll need 4 times 2 is 8. And finally, we always do oxygen last. Clearly, we have all the oxygens on this side, so we have 3 times 2 is 6 oxygens, and 4 times 1 is 4. So 6 plus 4 is 10. And so 10 will need 5. And see, that's why turbochargers are used to pump extra oxygens in. So you get a nice clean burn. And that's balance. You can now just basically check. 3 carbons, 8 hydrogens. 4 times 2 is 8 hydrogens. 5 times 2 is 10 oxygens. 3 times 2 is 6, plus 4 times 1 is 4. 4 plus 6 is 10. So have a go at that, and I hopefully it's a little bit making a little bit more sense now. Cheers.